Hello and welcome to Algebra 1, Lesson 6.1, Identifying Solutions of Systems. Today's objective is to identify solutions of systems of linear equations in two variables. A system of linear equations is a set of two or more linear equations containing two or more variables. A solution of a system of linear equations with two variables is an ordered pair that satisfies each equation in the system. So what that means is if an ordered pair is a solution, it will make both equations true. Let's take a look at some examples. In this example here, we have two equations, x plus 2y equals 6 and x minus y equals 3, and they want to know whether or not this is a solution of this given system. And here's what we have to work with. We know that our first is our x and our second is our y. So we're going to substitute or plug those in and test them out. So the first one, x plus 2y equals 6. We're going to substitute 4 in for x and 1 in for y, and we're going to see if it makes the statement true. So 4 plus 2 times 1, 2 times 1 equals 2. So 4 plus 2 equals 6. So it checks out. It makes that one true. In order for it to be a solution, though, of the given system, it has to make all of the equations within the system true. So we still have to test it out with our second example here, x minus y equals 3. So in this case, we're going to plug 4 in for x, 1 in for y, and we're going to see if it makes this statement true. 4 minus 1 equals 3. 3 equals 3, so that checks. So yes, this is a solution to the given system. Take a look at another example here. We have the ordered pair 5, 2, and we have to test it out with these two equations. So again, we're going to 2/5 x minus y has to equal 0. And we're going to substitute our values in. So 2/5 of 5 minus 2 equals 0. 2/5 times 5 is going to be 10 over 5, which is going to reduce to 2. 2 minus 2 equals 0. So 0 equals 0, so that one checks. So it's true for the first equation. Now we have to check to see if it's true for the second. We have 3x minus y equals 13. So 3 times 5 minus 2 equals 13. So we're going to do our multiplication. 3 times 5 equals 15. 15 minus 2 equals 13. So 13 equals 13 checks out. So yes, this is a solution to that system. And one more. We can see again, we have the ordered pair -2 for x and 2 for y, and we're going to plug them in to our equations. So -2 plus 3 times 2 should equal 4 if we've done it, if this is a solution. So -2 plus 6 should equal 4. -2 plus 6 equals 4. And 4 equals 4, so yes, that's true. We have to test it out still with our second. We have the opposite of x, or -1 times x plus y equals 2. So we're going to say -1 times -2 plus 2. And we're going to test it out. -1 times -2 equals 2. So 2 plus 2 equals 4. And 4 does not equal 2, so no, this ordered pair is not a solution to the system. Those are some examples of how we test the ordered pair to find out if it's a solution. In the second half of this video, we are going to look at the second part of our objective, and that's graphing the following systems of equations to find solutions. So in this case, we're going to look at our very first equation here, which is y equals x minus 3, and we are going to graph it. So the very first thing I can identify is negative 3 is my y-intercept. Think back to what we've covered so far this year, and we know that y equals mx plus b. This is our b, so negative 3 would be the y-intercept. We also know that we have 1 here for our slope in front of x. So that means we're going 1 over, 1 up, and we can plot a point, and we can do that to start to look at where our line is going to cross. 1 over, 1 down in the opposite direction. So we start to see what that line's going to look like. In the second equation, we have, I'll do this one in blue, make it a little bit easier to see, negative x minus 1. So I'm going to start at negative 1, and I have a negative x or negative 1x, which means I'm going to go over 1 and down, over and down. And you can start to see as I plot the points, over 1, down 1, over 1, down 1, and in the opposite direction. We can quickly see where those lines are going to cross, and then I will draw the line, and we can quickly and easily identify that our area of intersection is right here. So we can say that the solution to this, do that a little bit easier to see, 1, negative 2. That would be our solution. So we're looking at the point where the two lines cross. Let's take a look at the next example here. And we're going to do y equals x in red. We know that y equals x, there's no number that comes after the x, so our y-intercept is going to be our origin. And I can quickly see that I have a slope of 1, and I'm just plotting some points so that we see where that line's going to go. And I'm going to draw my... So you can see that I have my line that goes through the origin. It has a slope of 1. And if I look at the second equation, I see that we have negative 4. So I'm going to start down here, 3, 4, plot my point, and I have a slope of 3. So it's 1 over, 3 up, 1 over, 3 up, and I can see right away where my line is going to cross here. Do this line in black. Start to see that here is our point of intersection. So we have a point where it's 2 for x and 2 for y. So our solution is going to be 2, 2. We can check this really quickly by plugging in our values over here. So if I said y equals x, and I'm going to go with the solution of 2, 2, I can plug in 2 for x and 2 for y and see that that makes that statement true. And then I can do the same thing for the second equation, and I would plug in 2 for y equals 3 times 2 for x, and I can test it out, and I get 6 minus 4, which equals 2, so 2 equals 2, so that is also true. So we can see here in the second half of the video that by graphing our lines, using some of the things we've learned in previous chapters, we can look at where the two lines cross, and that's going to be the solution to our systems. If two lines don't cross, then we know that there is no solution to that system. So you can use this information, hopefully, to you do tonight's homework.